So go ahead and pause the slide and see if you can complete and balance these acid-base reactions from each base, and then putting what's left together to form a new ionic compound. So pause the slide and see how you do. Okay, so let's start out with the name of both of these. So the first one, ammonium hydroxide and sulfuric acid, based on the sulfate ion. So the first thing we're going to do is break apart our ions. Ammonium hydroxide is based on the ammonium ion and the hydroxide. And then let's take apart our 2H pluses and our sulfate. And then we're just going to switch our ions, and we'll make the compound based on the charges. So sulfate has -2, ammonia has +1, so we need 2 ammoniums for each sulfate. And then anytime H plus sees hydroxide, we form water. Now let's look at balancing. Alright, I have 2 ammoniums here and only 1 over here. So I'm going to put a 2 there. That also means that I now have 2 hydroxides. And I actually need 2 hydroxides because I have 2 H pluses. That makes a total of, here's my hydrogen that's in my water. Let me put my positive here. I have 2 hydrogens plus 2, which is 4. And 2 oxygens, 2 times 1 is oxygen. So when you have 2 H pluses and 2 hydroxides, you're going to form 2 waters. Now let's look at my state. This is an ionic compound, and ionic compounds with ammoniums are always soluble, and then water in these aqueous reactions is always in the liquid state. So it's balanced, and we figured out what the products were. So here's our second problem, and again, let's look at naming just to practice. This is aluminum hydroxide. Aluminum always has a +3 charge, so we don't need to indicate its charge. And here's our anion hydroxide, and this is based on the sulfite ion, so it's going to be sulfurous acid. Ite goes to us. Okay, so let's look at how we're going to figure out what we're going to get. Let's break apart our ions. Aluminum and 3 hydroxides, and then our sulfuric acid, and whoops, our sulfite. Okay, so now we're going to switch our ions. Okay, so I have aluminum, which is +3, and sulfite, which is -2. When I bring down the subscripts, I get aluminum, 2, and 3 sulfites. And that gives me a total of +6 from my aluminum and -6 from my sulfite. And so that works out. They both cancel out. 2 times positive, let's look down here, 2 times +3 is +6, and 3 times -2 is -6. So these charges cancel out, and there's the correct formula. Anytime I have H plus and OH minus, I form water. Now let's look at balancing. If I look back here, I have a 3 and a 2. I've got to get even numbers of both of these, and the least common denominator between 2 and 3 is 6. So I have 3 hydroxides here, and I have 2 here. I'm going to put a 2 in front of here and a 3 there. That way I have 2 times 3, which is 6. I'll have a total of 6 hydroxide, H pluses, and then I'll have 6 hydroxides here, because 2 times 3 is 6, and so that means I'll form 6 waters. And then when I put that 2 there, that takes care of my 2 aluminums and my aluminum sulfite. And when I put that 3 there, that also takes care of my 3 from my sulfite. So you may have balanced it a different way than I did, but if you got the same answer, then it's right. Now, what about solubility? Well, sulfite is not in our rules, and let's see what they say. They say it's going to be solid. So if it's not in our rules, we're going to assume that it's going to be solid. Okay, let's start out by naming these just for practice. Our first base is barium hydroxide, and we know it's a base because it has hydroxide in it, and this is one of our strong acids, sulfuric acid. Okay, now let's figure out what our products are going to be, and we're going to do that by separating out the ions. Barium is made of barium 2 plus and 2 hydroxides. Excuse me, barium hydroxide is made up of barium 2 plus and 2 hydroxides, and then sulfuric acid is 2 H pluses and my sulfate. Okay, now let's switch our ions. So barium and sulfate both have the same charge, opposite in sign, but both 2. And this actually is an exception to the sulfates. This is going to be solid if we look at our solubility rules. And then if we look at our H plus and our OH minus, we're going to form water. And we have an even number of, well, equal number of both, 2 H pluses and 2 hydroxides. So I'm going to form 2 waters. So that was not too difficult at all. And we look at our equation is balanced, 1 barium, 1 barium, 1 sulfate, 1 sulfate, 2 hydroxides, 2 H pluses, 2 waters. So if you got all these right, give yourself a big pat on the back.